Hey, it's Pavel. Welcome you to yet another video about building a Golang server application from scratch. And as for this episode, we will extend it with another storage provider, which is MariaDB. It is still not the ideal solution as for storing bit files, as the long blob column type allows us to store up to 4 gigabytes of data. For a comparison, Postgres byte A is supposed to be storing up to 1 gigabyte, although Postgres has some solution for bigger files, which is storing it in multiple records of that type. In the future, I will add some better options like using a file system to actually store the file, and the database would only hold a reference to that file, or we could use AWS buckets in S3 to store the files there. It also allows to store some tags as metadata, which if we would like to use the cloud, might be one of the best and easiest solutions. So to have it started, I have added some configuration for MariaDB, which is a set of environment variables. We have a database available in Docker Compose, which has a pre-installed schema just like Postgres. And I have added a test suite which should run tests on that MariaDB database. What we need to build it and be able to use that fresh provider is firstly a helper function for a MariaDB database. It will be almost the same as Postgres, so I will just copy it and add what's required, which is a driver for MySQL, as MariaDB is based on MySQL, which is it uses the same command, the same driver. We need to update the driver here as well, and we need to modify the raw connection string to match MariaDB specification. All the rest is exactly the same. So for close future, we could improve it by not multiplicating the that instance code and having one common provider for each the SQL database type. That would improve the process of adding new providers and modifying the configuration of currently used ones. And as for the connection string here, we need to update it to use the proper variables, of course. And the port, as for default, is 3306 for MariaDB, and the order of variables differs arbitrarily, and the actual format of connection string is user password. Then we have a protocol that we want to use for this particular connection, host and port, and then database name. And that's all in this section. We have a database connection ready to use, and now we can focus on our provider. So we need to add another type here. We need to add it here as well. And we can implement the queries. I have optimized it a bit as the general execution is exactly the same for MariaDB and Postgres. The only difference is queries, as MariaDB supports question marks for inserting parameters, while Postgres prefers dollar notation with exact order of the parameters. So this is the difference. It also could be modified as the main part is shared, so it would only insert the parameter list, but as for some cases it's quite it would be quite hard to do it without using this different notation. I have decided to keep it that way. And what we have now for the actual databases is a set of functions that moves us further to some shared implementations where we only need to pass the actual DB client, which also could be simplified if we decide to define that one common helper for all the SQL implementations, and we need to pass the query. As we can see, the Roland is able to tell us what's the string in question. So it will find the query for a given database and pass it to this function. We have such a set of function. We have the same set in case of MariaDB. And the only difference here is that we take a different query, and the MariaDB specific the database client, which, as you can see, massively simplifies the source code for each of providers, and all the execution we have in a shared file. So let's modify this file so we can utilize it for both providers. Basically, what we will need to do is to add a client, which is a nullable SQLDB type, and pass it here instead of getting an instance in each of the traces. And that is what we will do for each of the cases. Plus here we will add the query string as well. In the first case, it's not really needed as it's a constant, and it's exactly the same for each of our databases. One nice thing about Go is that we have a few input parameters with the same type. We don't need to specifically define the type for each one, but it's enough to put it on after the last one of these parameters divided by commas. It also simplifies a bit what we have to do here, and still is quite easy to read. Like that, we don't need to write the same stuff many times. It's nice, it's easy, and implementing another provider like just MySQL or Oracle or something would require only adding the SQL codes if they differ from the ones that we already have here. Because also it would make some mapper between the various types, not to multiplicate what we already have. So we have quite a lot of options for optimizing the code. I will try to add at least some to the final product to make it readable, small, and easy to maintain. Let's finish it up. 2 more functions, and the last one, and delete. And we are quite ready to go for now. We have added database client implementation. We have added a provider, so let's try to test it. I will start with Postgres to check if it still works, and we have some issue as I see. As we can get content, and I think I know what I have forgot about, which is we have switched the order of parameters. As you can see, for content, we firstly set content as the first one, and then we update. We set ID, so it should now match the order here. In Postgres, we tend to use that predefined order support as we have it shared, but it's not a big issue, I would say. Taking that, we can reuse a lot of code currently, and Postgres is passing. MariaDB should be passing as well, and yes, we are altering, so we have positively added a new storage provider. And as mentioned, adding the new ones would be even simpler due to what we have implemented as for this shared support. Thank you for your attention, and welcome to check the other videos.